Guys, hi everyone. Let's take a look how do we gonna find the integral of these uh, rational function. Okay, so first of all, we need to factor the denominator. Factor denominator. So for the denominator, it looks like it's not quadratic. However, if you look at the first and the second term, they both have x. So I'm gonna take out x, and then I will do x and then x squared plus 3, because if you multiply back the x times x, you're gonna have x cubed, and then 3 times 3, you're gonna have 3x. Okay, so this is our factor form, and the numerator, I will leave it at what it is. Now we're gonna decompose this. So remember, when you have the linear factor in the denominator, we're gonna have a constant on the numerator. So the x right here, we will pair with the a. And then you're gonna have another expression, which is x cubed plus 3. This is irreducible. This is irreducible. So when it's irreducible, we're gonna have to use the linear uh, expression for the numerator. So I'm gonna do bx plus c and all over x squared plus 3. So just did the same way that we did in class. We're gonna cross multiple and then drop the denominator. So I will have x squared minus x plus 6 equal to a times x squared plus 3 plus x times bx plus c. Okay, and there are two ways that we can find out what the ABC is. In class, I actually show you one way, and I know there's then another group using another way. So I'm gonna use that on here as well. So just in case you need that way and feel it's better. So I'm gonna distribute everything on the right hand side. Then I will have ax squared plus 3a plus bx squared plus cx. Okay, and then combine like term. It looks like I have the like term for the a and b is right here. So for a and b, we have the like term. So I'm gonna combine like term by taking a plus b times x squared. Okay, so this is confirm that. And then I have cx and 3a. This, the expression on the right hand side must equal to the expression on the left hand side. What does that mean? That means their coefficient must be the same in order for these two expressions are equal to each other. So we're gonna set the coefficient equal to each other. We have the first coefficient for x squared on the left side is 1, because there's nothing in front mean 1. And the right side a plus b. So that means I need a plus b equal 1. Okay, a plus b equal 1, because they must have the same coefficient. Now for the next coefficient is -1 for the x, and on the right side I have c for the x. So it means c must equal -1. So c must equal -1. And then the last term is the constant term. The constant term on the right side, 3a, the left side, 6. So they must equal to each other. So 3a must equal 6. And from that, a is going to equal to 2. With that being said, you have c equal -1, a equal 2, and you have a plus b equal 1. Then I can use the a to find b. So I'm gonna put that in here. So I have 2 plus b equal 1. So my b is equal -1. Perfect. So we are finding three of the value for a, b, and c. All we have to do is put back into this expression, the one above before we do this. Okay, so we're gonna put that in there. So our integral, whatever we have here, will equal to 2 over x plus negative x minus no, not minus c, minus 1 over x squared per 3. Okay, so I just replace all these number on the for the A, B, C above, and then this is what I get. And then remember, when we do this type of problem, it's better that we're gonna decompose this one as well because the U sub may not work for this. So I'm gonna go ahead and separate this one more time. So we will have 2 over x plus negative x over x squared minus 3. So I'm gonna separate this way and then that way. Okay, so we're gonna have negative 1 plus negative 1 over x squared plus 3. And we need to integrate all that individually. So we have 3 integral to integrate. The first one directly using ln, and the last one we can use table. The one in the middle, you're gonna have to use u sub. So I'm gonna take care of the first one first. The first one, we're gonna have 2 ln x, no problem with that. And the last one, we use table number 17, where you have 1 over a squared plus x squared dx will equal 1 over a arctan x over a. So my a in this case, a squared is 3. So my a should be square root of 3. Okay. So in this case, my a squared is 3. So my a should be square root 3. So the answer for this one, the negative, this doesn't have the negative. So we can keep the negative and put that in the front. So we have negative 1 over root 3 arctan of x over root 3. And then of course, plus c at the end. And then the one in the middle, we're gonna use u sub. So when there's a fraction, we're gonna let u equal denominator. U equal x squared minus 3. So du is 2x dx. But our numerator, I only need negative x dx, okay? So we can, instead of just get x dx, you can divide 2 on both sides, or you can divide 2x on both sides, whatever comfortable with you, okay? So I'm gonna divide 2 both sides. I have x dx. Then my integral x with the negative in front, x squared minus 3 dx now will become, this thing on the top will become du. So I have negative du over u, which is just 1 over u, okay? Or you can write 1 over u. 1 over u du. And that will negative ln u and will be negative ln of x squared minus 3. So put that back in there. We have minus ln of x squared minus 3 to be our answer for number 5.